Hello and welcome to the Project 1 CAM series part 3, post-processing. In this video we're going to go over how to take all the setup and toolpath information from the first two videos and translate it into machine-specific G-code for running on a CNC machine. We're also going to work on creating our setup notes, which is going to have a bunch of really useful information for the machinist, as well as creating the setup sheets, which is going to kind of have a full breakdown of the entire program. So yeah, let's get started. Okay, so at the end of the last video, we had just finished the toolpaths, but there's still some things we need to kind of figure out and wrap up before we can send this thing off for machining. And let's do that by editing our setup notes. So to edit your setup notes, right-click Setup 1 and say Edit Notes. And there we are. Okay, so what goes in the notes? Well, kind of anything you think is important, anything you want the machinist to know, even if that's you in the future, you're going to put in the setup notes. It could be all kinds of things depending on your setup and your workflow, but I have a few things that I think are kind of important. So let's start with this. First thing I'm going to say is using G54 for a work coordinate system, WCS. And that just means that in the program we set G54 as the line where the information in the machine for the location of the WCS is going to be saved. So just in the machine, whatever machine it's using, when you're using it to find the stock material, you should have it save that information on the G54 line. It's usually by default that's what happens, but this is just making it explicit. What else we're going to say? We're going to say work WCS is at top center of stock. What else is important to know? We're going to say all speeds and feeds are for aluminum. And this one's good. After cutting stop, measure actual stock size with calipers. Input actual stock size into setup 1. Regenerate toolpaths and post process G code. Okay, what does that mean? Well, let's take a look. I'm going to go ahead and click OK. And I'm going to right click on setup 1 and go to edit it. Okay, now if we go to the stock tab, these numbers here for the value of the size of the stock, we just kind of guessed at based on stock that we think that we have in the shop, and about where we think that we're going to cut the length of it. But this might actually change when we get the actual stock in hand. There's two ways of dealing with this. You can either do something to the stock to make it exactly this size, or more often you will come in here and adjust these values based on what the actual stock measurements are. So let's say that we ended up cutting our our piece of stock to length at 2.35 inches. If you click OK, it's fine. It kind of automatically updates it, but all these toolpaths are now out of date because the location of the toolpaths, the number of passes, all that kind of stuff really depends on the size of the stock, and we've changed that, and we have to recalculate all of these toolpaths. So you can either, if sometimes you'll do some change and it'll make you require you to regenerate one toolpath, and you'll see that little orange circle next to it. But since we have to do all of them, I'm just going to right click on setup 1 and click generate, and it should recalculate all these toolpaths, and you get the little green check mark next to them, and we see that we're good. So that's how you update stock size. It's really important to update stock size because if your stock is larger than, if your actual stock is larger than it is in here in the program, you will likely get your tools over engaging with material at certain points, which can be dangerous. It could break your tools, it could dull your tools, it could cause a part ejection, all kinds of bad things. So yeah, if you also if the stock material you actually have is smaller than is in the software, your part might not fit in it, or it might be offset so much that it kind of comes out the side of the stock, and then you don't actually get the full finished part. So yeah, you'll need to really update that stock size. Really important. Okay, what else? Let's go back to the machining notes. And what are we going to write next? Next, we're going to say minimum part stick out equals, and I'm just going to click OK. So we have to calculate the minimum part stick out, and we have to do this for every setup of every part that we machine. It's actually really important. And what it is, the minimum part stick out, it is, you can think of it in two ways. It's the minimum amount that your stock needs to be sticking out of the vise in order to avoid collisions. You can also think of it as the distance below the top of the stock that the lowest tool goes. So what you're trying to avoid here is your cutting tools colliding with your work holding. So your end mills hitting your vise or your clamps or whatever it is. And the way that you can do that is that you can calculate the minimum part stick out here, make a note of it, and then when you get to the machine, you can check it because you know the actual value that you're working with. So how do we figure that out? Well, it is not straightforward, and it's going to be different for every setup. I mean, it might not be different for every setup, but it is not a formula that you can write. And some of these values we're going to have to remember choices that we made earlier. So it's not totally straightforward. But one way that I like to try and figure this out is I like to look at it from the side like this. I like to click on the setup so I can see the stock material. And then I just kind of hover over the different tool paths and I can see their lines show up. And I kind of see, okay, which one goes the lowest? Okay, that one goes pretty low. What else? No. That one goes pretty low, but this one goes a little bit lower. Okay. And the chamfers kind of stay up high. Okay. So it looks like the drilling toolpath goes lower than the contour toolpath on the outside. However, that drilling toolpath is completely inside of the stock material. So the tool doesn't actually leave the stock, so there's no fear of it colliding with the work holding or the vise. Whereas the contour that goes around the outside, it could definitely hit the vise if the stock material is too far down in the vise. So yeah, we need to figure out this number. I'm going to turn off the drill here, and we can calculate this number. So the way that we have to figure this out is, okay, how do we figure out the distance between top of the stock here with this line down here that represents the lowest that the tool goes? Well, there's no way to measure from there to there. So what we have to do is we have to remember, okay, so how far off the top is this part sticking down? Well, that was actually in the setup one. If we go to edit in the stock section, we can see that model position was offset from top and the amount was 0.05. Okay, so we're gonna write that number down, 0.05. And then we also need to know, we need to know the distance from the top of the part to the bottom part. So we can measure distance from the top of the part to the bottom of the part, 0.75. Okay, write that number down. And the last little bit is this distance here, the distance below the bottom of the part and this toolpath here. And that should be in the toolpath dialog box itself. And it is in the heights tab, and it is this value here. It's the distance below the bottom contour that we selected, and that's how far the tool is going to go during machining. Okay, so write that number down too. All right, let's go back to our machining notes. And so in this case, I'm going to write it out. Minimum part stick out equals offset from top plus part thickness plus offset from bottom equals, okay, offset from top was 0.05 inches plus part thickness 0.75 inches plus offset from bottom 0.02 inches equals 0.82, I believe. 82. Okay, so that is our minimum part stick out. So what that looks like when we measure that thing is after we get our stock held down on the machine in the vise, we're going to measure the distance from the top of the stock to the vise. And that distance has to be greater than 0.82 inches. If it was exactly 0.82 inches, you might still actually hit the vise because there's air all over the place. So you want it more than that. How much more? Well, it depends on what you're comfortable with and your experience level. But you have to kind of balance that with the amount of stock that you have clamped in the vise, which in most cases is a minimum of 1/8 of an inch. So yeah, it's kind of a balance. You have to find the way, but knowing that 0.82 number is key, and you're gonna have to know that for every part that you machine. Okay, so it looks like we have our notes, machining notes, and the next thing to do, I think, is to make our setup sheet. So our setup sheet is where a lot of really, really good information about our part or about our program kind of lives in one place. Basically a PDF that has all the information in it. Really important for setting up a machine, and then for running the program, you can kind of go back and see like what's supposed to be happening. It's kind of a good reminder of all the details. So to do it, first thing I'm gonna do is I'm actually gonna get an isometric view of this thing. Isometric view is when you're kind of looking at the corner down at an angle like that. I can get close here, and I like to click on the corner, boom, to actually get a real, true isometric view. Okay, and now what we're gonna do is right-click Setup One and click on Setup Sheet. And you will get this document. This folder that opens up. It might look different depending on what kind of computer you're on, but just click through it, either select folder or I forget what the other one is, and it'll actually open it in a browser bar, in a computer browser, in a web browser, sorry. And it'll look something like this. So we can see Setup Sheet has the program comment at the very top, which is like good. You can write whatever you want in the comments, and it'll show up right there in the setup sheet. Setup One. At the very top here are our machining notes. So all that information you want to pass on to the machinist is right there. We have here stock dimensions, part dimensions, WCS location. We have number of operations, number of tools, tool numbers, maximum Z, minimum Z, and maximum feed rate, all that stuff. Then we have the tools in order of tool number 1, 2, 3, 4, and 5. So it tells you which tool is which, and that's really important because when you're setting up the machine, you're going to need to know tool number 1 refers to the 2-inch face mill. Tool number 2 refers to the 1/2-inch flat end mill. That's really key because if the machine has the wrong tool number associated with the wrong tool, it's going to try and do the facing operation with a drill bit or with a chamfer mill. It's not going to go very well. So coordinating tool numbers in the machine is really key. Coordinating tool numbers with the program is really key. Then you have your list of operations. Operation 1 of 12, facing toolpath. Then we have an adaptive with a 1/2-inch end mill, and then a pocket with a 1/2-inch end mill. And really the machinist has to know all of this stuff because they have to know what to expect on the machine, because if for some reason there's an error in the code or the wrong program is running or any other number of bad things that could possibly go wrong, they have to be able to catch it early before something bad happens. And knowing what the program looks like is really pivotal in for kind of being able to do that. So they have to know what the order of all of these things. So all the information is there. I will do a little bit of check on our 0.82. It's kind of a nice way to do this. It does say minimum Z is 0.895, which is more than that. However, that number is associated with the drill bit here, because remember it went a little bit lower. We said negative 0.895, right? But it was all internal, so we don't have to worry about collisions. The tool that actually goes down and does the perimeter is this 1/2 inch end mill, and it has a minimum Z of negative 0.82 right here, which is what we calculated. So that's good. It's a good check. But you can't just rely on minimum Z to give you the exact answer, because in this case, it wasn't the most important minimum Z, or wasn't the one that we needed in order to make sure that we weren't going to get a collision. Okay, so that is setup sheet. I would recommend printing this or saving it as a PDF, and you just go to your browser and do Control P, or file print, and save it as a PDF or print it out. But note that if you make any changes to your program, make a stock change, make a change to your part, change a tool order, or then your setup sheets aren't going to be valid anymore. So, I'll kind of make these right before I go to program, or right before I go to machine my part. And if you change anything, you need to make new ones. So they're only as accurate as they are current, I guess. Okay, so those are setup sheets, really important. The last thing that we're going to do is we are going to post-process the G-code. And what does that mean? Well, that means we are going to translate all of this information about setup and the location of the work order system with the stock and all the tool paths. Effectively, we're going to take all that information. We are going to translate it into machine-specific G-code. And so the way that you do that is we're going to take setup one here. Well, I know that the machine I'm going to has a tool changer on it. So I'm going to post all of these together. I'm going to right-click on setup one and post-process. And then we get over here, post-process dialog box. Okay, so the first thing we need to do is we need to select a post-processor. And so I'm going to click on here. Let's see. Let's go to choose from library. These are all post-processors that I've used before. But if you haven't used one yet, if you haven't set one up yet, you'll have to choose it from the library. And yeah, let's see. Let's go to the Fusion library at the very bottom here. So post-processors are very machine specific. So, let's take a look here. I'm going to post for a Haas mill. But there are a bunch of different types of manufacturers that make post-processors for all of their CNC machines. And if we look at Haas, though, Haas has a lot of different post-processors, right? And that's because they have different machines, and some of the machines are very different from each other, and they require really specific kind of translation devices or post-processors here in order to make code that works with that machine, right? They also have certain post-processors that work with multiple machines, right? So, for instance, there's the older Haas's, older Haas mills. A lot of them use this Haas pre-NGC post-processor, and that'll work on multiple machines. The one I'm going to post for is the newer machine, which is a Haas next generation control. It'll give you a little bit of information about it here. If you're unsure about which post-processor your specific machine will require, check with the manufacturer. Sometimes they provide you with a post-processor. Other times you could check with the Fusion team or on the Fusion website, and they will kind of have information about, okay, if you have this machine, you should use this post-processor. So I'm going to click there, Haas Next Generation Control, and select. And then it's going to ask you to save it someplace. And then you can save it like in your cloud. It's probably a good place to save it. My posts cloud. You can save it locally. It's not letting me save in my cloud. Might be because I already have this in here. Yeah, a bunch of times. I'll save mine locally, but you should save yours in the cloud if you can. Copy to my posts. Okay, and now because we're going to go to the program name number, 1001 is fine for most applications. You're limited sometimes in terms of what you can put here by what your machine can understand, so know what your machine is expecting. There's a comment if you want to change it here. Output folder, this is where it's going to save this file, so just make sure you save it someplace that you can kind of get to. So I'm going to save it to the desktop. Okay, what else you could do? Units, document units, if you needed to switch it between different ones, you could change that here, but we're just going to say document units. We said that as inches early on. If you click open NC file in editor, you can see the G code. Not necessary, but you can kind of see it. We'll take a look at what it looks like. Okay, and then you can make save an NC program in the create an NC program in the document, and I'll show you what that looks like too. Then you have your post property configuration, and that's what's happening here on the right. And different post processors will have different things over here, and this is all about like the specifics of your machine, right? So maybe you have a Haas that uses a next generation control post processor, but it has an A-axis rotary or a B-axis or a C-axis rotary, and you would specify that here, and then it would post that in the post processor. You know, any of these things that you need that are really specific to your machine or different like kind of settings that you want to change, you would change here. You know, you really kind of got to know what you're changing here, but because it's possible to change some things that are not that you know might result in kind of things you weren't expecting in the machine. So just make sure before you make any changes here, you know what they are and you know what they're going to be doing. So for instance, I know that I'm going to uncheck preload tool. Actually, no, we're going to leave that checked. You know, because I know that my machine can do that. I'm going to say use G0, which has to do with like the rapid movements. And what else? G187 off. These are all just kind of like, you know, generic things. Or specific things. These are specific things to your machine. So you get to know your machine, know what specific things you need to change in the configuration based on your machine setup. And you know, once you do this, it'll kind of save that configuration, so you don't have to do this every single time. You just kind of have to do it the first time. Okay, so once that is all set, we are going to click Post. Okay, it might ask you to download something so that you can see the G code, like a text editing software, and then you get a little kind of warning in the corner, or a little message in the corner saying that the G code processed correctly. And then once the file has saved, if you check to open the G code, you will see the G code here in the NC file that you just generated with your post processor. So we can see that the code starts out project 1, setup 1, Steve Thompson, and that is in parentheses, and that means it's a comment. So everything in parentheses is a comment. It's not going to actually run anything on the machine. Gives a list of tool numbers, and then it starts giving some G code here. And then this one, G53, means machine coordinate system. G0, which is rapid. Z0, which is to the Z0 position. It's going to go all the way up. Then we have the facing operation, face 1. T1 M6 means change tool to T1. S1910 is spindle 1910 RPM. M3 is clockwise. And that you kind of go through the G code that way. There's, you know, G code and M codes here. M8, turn the coolant on. You don't need to know all of these things, but it is really useful, especially when you're at the machine running the code. Then you kind of know what it means. You know, there's a lot of geometry stuff in here, and especially when you get to the adaptive toolpaths, it gets really heavy. It's just all just movement stuff, right? And they get really long. They're very calculation intensive toolpaths, right? So as you do this more, you'll become more and more familiar with the G code. You can see another toolpath starts here, 2D Pocket. But all you need right now is this NC file. You're going to bring it to your CNC machine, and then you have to, you can run it on your machine. Learning how to run your machine is a kind of a totally different skill set, and it really depends on the machine that you're using and how whoever made it set it up. All right, so I'm gonna close this out. Okay, and I think that is it for post-processing. We have our setup sheets, we have made our machining notes, and we created our G code for machining project 1. Yeah. So next step for you is to machine project 1, and then move on to the CAD and CAM for project 2. Yeah. So I will see you there.